Differences between lasers and other light sources. To understand the technology used by the LAPEX 2000 BCS, it is important to examine the difference between laser light and the light produced by other devices. Light bulbs emit a diffused, multidirectional light made up of multiple wavelengths. LEDs, like those found on your car radio or alarm clock, emit non-coherent light. This light is composed of a narrow band of monochromatic light at a specific wavelength. Laser light, in contrast, is composed of coherent light. It is purely monochromatic, directional, and has a single specific wavelength. Laser light is polarized, which means it can be concentrated onto a defined location or spot. These characteristics are important because they are the basis upon which the LAPEX 2000 BCS technology is built. Laser terminology. When dealing with laser technology, it is important to familiarize ourselves with certain terms. Photons. The photon is the basic unit of light and all other forms of electromagnetic radiation. It is considered both a wave and a particle. Wavelength. A wavelength is the distance between repeating units of a propagating wave. Every photon has a specific wavelength. The wavelength of a laser is measured in nanometers. The LAPEX 2000 BCS has a wavelength range of between 630 and 680 nanometers. Laser light at these wavelengths is used in medicine for biostimulation. In our case, it is used to stimulate the release of fat from the adipocytes. The electromagnetic, or EM spectrum, is the range of all possible electromagnetic radiation frequencies. EM radiation, with a wavelength between approximately 400 nanometers and 700 nanometers, is detected by the human eye and perceived as visible light. Photons with a reddish color have longer wavelengths than photons with a violet color. The shorter the wavelength of a photon, the more energy it carries.